Hello, and welcome to Chapter 8. In Chapter 8, we are covering OSPF, OSPF single area. So in OSPF, you can have multiple areas, in fact, not just a single area. And that's what makes it so widely deployed because it's very, very scalable and it's very easy to, not easy to configure, but it's a much more useful routing protocol than RIP2. And of course, like we've discussed in the last chapter, it's a link state protocol, and its convergence times is very quick, and it can operate on non-Cisco routers as well. Okay, so remember those characteristics of OSPF. All right, so we are going to cover the characteristics of OSPF. Then we'll go on packet tracer. I'll show you how to configure it using IPv4, that's version 2. And then we'll take a look at version 3, configuring OSPF using version 3. Version 3 is very, very easy, very similar to what we did RIP2 when we did it in the last chapter. Okay, so this is the objective. The theory is a little bit more involved, so just pay attention. We'll discuss that as we go along. A little bit more involved than RIP2. All right. Anyway, excuse me. So version 2 is the one that is using IPv4. Version 3 is the one that is capable of using IPv6. Advertising and configuring IPv6 networks. So that's what we're going to be looking at both today. So features of OSPF, it's more efficient, fast convergence. In fact, all it does is once it learns all the networks around, it will never, there's no periodic updates with OSPF. And unless there is a topology change, and what that means, if you inserted a router or took out a router, or in other words, you type shut down on an interface, that changes the topology. Or you put a new interface in and you type no shut, that also changes the topology. That would immediately triggers an update. Otherwise, there is no updates. And that's one of the reasons it's fast convergence. Scalable, easy to expand, right? Like I told you just a few seconds ago, OSPF can be used in multi areas. So we're going to start with the backbone area, area 0. We have to do that first. So in this chapter, we are going to be only considering and working with area 0. We're going to be configuring routers in one area called the backbone area, area 0. Now, next semester, I think, if I'm not mistaken, we'll be doing multiple areas. So we'll have 2 additional or 3 additional areas connected to area 0, the backbone. That's a multi-area. It's very easy to expand from one area to another. Okay, so that's why a lot of people love to use OSPF. It's secured because you have your own areas to work with, and it's classless. It can use VLSM, CIDR, and now we have OSPF version 3 that can support IPv6 as well. All right, so the components of OSPF, it has 3 tables. The neighboring table, what they do is they send out, if you are an OSPF router, you send out hello packets to your neighboring router. Say, hey, hello, I'm here. I'm running OSPF. And then whoever responds back to you, you know that you are your neighbors. So you can use the command show IP OSPF neighbor to tell you who your neighbors are, because you are the one who are going to be receiving updates from you and sending them out to everyone else. Then after you get in the information from everybody in your LAN, you are going to create a topology table. Topology table means uh, the networks that you're trying to reach in from every direction. So it's a huge table. You can type show IP OSPF database. For example, if you're located in one area and you want to go to a different location, and there are different routes to that location that you're trying to reach, the topology table will have all the directions and how much it will cost you on each direction. And then you run an algorithm on the topology table. For OSPF, that algorithm is called using the Dijkstra algorithm. If you remember, we talked about that, I think, chapter or two ago. And when that algorithm creates a OSPF tree and picks the best route to that location that you're trying to reach and insert that in the routing table. So and then the routing table, you can type the command show IP route to display the routing table entries. So there are three tables that are created in OSPF: the neighboring table, the topology table, and the routing table. All right, so routers, if you run OSPF on this router and you run OSPF on the other router, then they send hello packets to each other. They send data description, link state requests and updates. So they talk to each other before they send what networks they are connected to, and so on, before they build a routing table. So they exchange packets between each other. All right. So for example, so the hello packets, you send hello packets to everyone. Hey, I'm your neighbor. As long as you are within the same area, you want to establish a neighbor adjacency with that neighbor. Okay. So that grows. Then you send the LSAs, the link state advertisement. You advertise, as we will discuss later on, your router ID numbers because you want to elect a designated router and backup designated router, which we'll discuss in a few minutes before you build your routing table. So that's you can send LSAs to all your neighbors that you connected to. And like I said, once you do that, once you get all the information, then you create the tree. Here's a topology table with a huge topology table. Every destination with every direction, with every cost on all of them. And then you run the Dijkstra algorithm on it, and you build a tree, and you pick the best route from that tree, and you insert that in the routing table. All right, so here's a typical topology table, right, and all the costs, the tree, and then you pick the best route and you put it in the routing table, right? Actually, these are different directions. So this is actually the routing table, right? So this is the best route. This is the shortest path, and it cost me 22. This is all of this information. The Dijkstra algorithm got all of that information from the topology database, and this is your routing table. Okay, so you can have a single area called area 0. That's the backbone area. And all the other areas have to connect to that area 0. But you have to create area 0 first. You cannot start with area 1. So in our chapter 8, you should never ever write anything other than area 0, because I remember students tend to write, they write area 0 here and go to the other router, they write area 1. No, both routers, all 3, 4, 5 routers, they are all in the same area 0. It's called an autonomous system, right? So they all have to be in the same area 0. That's the backbone. Now, next semester, when we create another area, that that other area, let's say area 51, can connect to area 0, the backbone. But area 0 has to be connected first. That's important, right? All right. Now, encapsulating OSPF messages. Now, these are good to know. I mean, not necessarily the best. Well, I don't know. Cisco has them, so might as well. Let's talk about it. These are the OSPF messages that are encapsulated and sent between routers. Okay, and the headers and the trailers that are placed on them, the IP packet, you have a multicast address when you're sending out updates, a multicast address, and when you are receiving updates, depending on what you're doing, if you are sending or receiving updates to the backup or the to the designated router or the backup designated router. Okay. All right, and here are the different types of packets that are sent between routers. Type 1, 2, 3, 4, 5. So again, these are good to know, not necessarily need to know when you are configuring your routers out there. So knowledge-wise, you need to know them because you'll be tested on them on your CCNA or even on your regular exam. So make sure that you know the 5 different types of packets that are sent. Okay, so here's question number 1 for you. What are the 5 different types of OSPF packets out there? Here they are. So please to write this down, create a table and write this down. The 5 different types of packet. I want you to write them down and submit that in homework. There are additional. Now we're also going to do um, a packet tracer as well, and other questions will be asked later on. Anyway, so packet number 1, the hello packet. That's the packet that goes out and and asks for neighbors. Says, hello, I'm your neighbor. And, the guy on the other end, it's connectionless. He doesn't have to respond back to you. And also you can use the hello packet to elect a designated and a backup designated router. I've been talking about designated and backup designated router in a few seconds. We're going to discuss it in details. And you only elect a designated router and a backup designated router only if you are on a multi-access network. If you are directly point to point, like 2 routers like we had in the previous example, there is no need to elect a designated router. All right, here are the packet content of the hello packet with all the fields that are stamped on it. Again, these are good to know, not need to know. By default, every 10 seconds, you send out a hello packet using the address 224.00.5. If it's IPv4, it's FFO2 colon 5. It's an IPv6. Every 30 seconds, if you are on a non-broadcast multicast address like point to point, dead interval is I think it's 4 times, which is 4 times 10, which is 40 seconds. And by the way, to be a neighbor with OSPF, that's another question. When I say hello to you and you say hello back to me, you have to respond with a couple of things. You have to agree to 3 things if you are going to be a neighbor. So that's question number 2. To be an OSPF neighbor, you have to first agree to the hello interval. So if every 10 seconds I say hello to you, that means we both agree that we're going to say hello to each other every 10 seconds. So that's checked. That's good. So the hello interval has to be agreed upon. The dead time interval has to be agreed upon too, which is usually 4 times the hello interval. For example, if we agree to each other that, excuse me, every 10 seconds we're going to say hello to each other, and if after 40 seconds you didn't say hello, then I consider you to be gone, done, dead, right? So we both have to agree to the hello interval, the dead time interval, and the third thing is the protocol. Which packets are we going to exchange with each other? And typically it's an IP packet. So those are the 3 criterias that you have to make sure that you agree upon before you become a neighbor. The hello interval, the dead time interval, and the protocol, which is typically an IP packets. All right, so here are some link state updates. In the link state updates is where you send your, an update is like it includes all the link state advertisement in there, a whole bunch of advertisement, everything. It might contain autonomous system LSA, summary of LSAs, a whole bunch of different LSAs together. in one shot, not just advertisement, but information that you probably need to use. Okay, so the OSPF operational state. What you do is you go in, you create adjacencies, then you exchange router information, and once you do that, then you calculate the best route to the destination. And you, after you do that and you create your routing table, then you really, the network has converged and you're ready to start routing packet. And that means you are ready in the full state. Now, when you are establishing adjacencies, you have to establish adjacencies with your neighbors. You say hello. Yes, you say hello back to you, and you have to agree to those three characteristics: the hello interval, the dead time interval, and the protocol. And if that's the case, then um, you are a neighbor, right? Now, if you are on a multi-access, you're going to have to create adjacency. Everybody is your neighbor, right? So therefore, you need to have, instead of, if you have a lot of routers, so let's say 15, 26 routers, and you have to create, 1, 2, 3, 4, 5, let's say if there's 15 routers. So that means you have to create neighboring with 14 routers. And everyone has to create a 14 neighboring router. And then when you want to send your updates, you have to send it to 14 routers, and every other one has to send it to 14 rounds. You know what I'm talking about? So it grows. It's very, very large. So therefore, to do that, the best thing to do is to designate a router where you will send your updates immediately only to, what you do, you will send your updates to a router instead of one router. Will designate a router where everybody sends that update to that one router. And from that one router, it goes out to everyone else. Okay? All right, just give me 1 second and I will return in 1 minute. I got to do something really quick. Okay, we are back. So let's continue. Going back to the designated and backup designated router. So, like I said earlier, uh, to avoid having so many, let's say here, you have everybody connected to this one switch. This is called broadcast area. So that everybody's connected to that switch. So this guy right here has to make adjacencies with 5 routers. So is this guy has to make adjacencies with 5 routers. So the number is going to grow very, very rapidly when you have to exchange updates. So what we do is we will elect one router to send all the updates to, and then this router will send the update to everyone else. This is the router that we elect that's going to receive all the updates is called a designated router. And of course, we want to make sure if that router, that designated router, the DR, fails, there's going to be a backup designated router, the BDR. So we'll elect a designated router and a backup designated router to make sure that occurs. Now, here's the election. How do we elect a designated and a backup designated router? Let me just go back right here, go back previously. So when the routers go up, this is what we're going to do. So I wrote them down for you. I want you to write these down. This is also all of this down. So how does a designated and a backup designated router election occur? The first thing that happens, the routers are going to elect, the routers will elect the router with the highest OSPF priority number. So anyone that has so what the routers, what they send to each other and they say, hey, what's your OSPF priority number? By default, everyone has priority number 1. So because everyone, if you don't change the priority number, then the router say, all right, we have to choose something else to elect a designated router. Then routers will use their router IDs. Everybody will pass their router's ID to each other, and then they'll pick the router with the highest router ID to be the designated router. Okay? Now, the best thing to do, of course, is go to one router. If you want that router to be you manipulate the election. You go to one router, go to that interface, fast Ethernet 00 that's facing the switch, and you say IP OSPF priority 200, something higher than 1. If you make that and you clear the OSPF process, then the router immediately, that router will be picked as the designated router because everyone else still has priority equal to 1. And if you want the backup, you just make another one, the OSPF priority equal to 200 on another router, and that will be the backup designated router. Okay? Here's another question that comes up on the CCNA. How do you make sure that a router will never be elected as a designated router? Just go set the priority equal to 0, right? Therefore, we make sure that he will never be elected. Anyone else is fine because they all have 1. Now, what happens when you go, how do you, that's it. Now, if the priority stayed at 1, then you, like I said here in step number 2, then the routers are going to elect the router with the highest router ID number. Now, that means every OSPF router must have an ID, a router ID with them before they start passing it to each other. So how does the router create or configure its own OSPF router ID number? When you first turn the router on, now you can go into the router and say, you go into router OSPF and you say router dash ID, and here's your router ID, which is really just an IP address. The higher this number 192 is, let's say, higher than 191. So the more significant number will give you a higher router ID number. Now, so you can manually configure to a static router ID number using this command. Now, if you don't want to use that, if you did not do that, then the router will say, hey, I still need a router ID number. So he goes in and looks if you have configured the loopback address. Remember we created a loopback address in the last chapter. We type interface loopback 0, that virtual interface. If you created some virtual interfaces, it will look at all the loopback addresses, the virtual interfaces that you created on the router and pick the highest one as the router ID number. Now, if you didn't do that either, it's going to pick the highest interface, active interface on the router, physical interface, and use that as the router ID by default. Okay, so by default, if you don't do anything, no priority number, nothing, your router ID will be used as your highest active IP address on the router, and that's not good. So you definitely want to manipulate the election. The best thing to do it is to change the priority number, and we'll see an example. Okay, so please write this down as part of the homework. I want you to submit this also. I want to make sure you know how the election of a designated and a backup designated router occur, and how an OSPF router ID is configured, because that is part of the election, especially if you did not change the priority number. Okay, let's continue. So you definitely need a designated and a backup designated routers where you can send your updates to. Let's assume that this is the routers that designated. So everybody, once the election occurs and a designated router has been picked, that designated router gets all the information. He creates the database, everything, and we just go into that designated router, get all our information from it about our neighbors and who's our neighbors and all the network. So that's very, very important. And so if that goes away, the backup takes over. That's why we want to manipulate the election and make sure we know who is going to be the designated and the non-designated router, right? All right, so first, if you are directly connected, like I said earlier, there is really no need to create a designated and non-designated router, by the way. Okay, this is going through two routers by synchronizing the databases to make sure, They talk to each other before they send any information back. These are good to know. So here's how you would set up the router ID. You go router OSPF. This is how you activate OSPF, and you write a process number. This number could be any number. It really doesn't matter. I usually write 1, and then you can set the router ID in there if you want to. And the router ID, by the way, when you set it either for IPv6 or IPv4. You still use an IPv4 number. 11111, 2222, or 192.168.10.3, whatever. This is how you would set the loopback addresses. Remember that? You can clear the IP-OSPF process after you do any of these, so these can take effect, right? Instead of rebooting the router. We'll take some example. All right. Let's take a look on how to configure OSPF. So let's go to Packet Tracer. So what I did is I already built a Packet Tracer for you, and I want you to grab. So go ahead and grab here. Grab a 2811. This one right here. Put one right there. Put router 1 there, and put another one right here. So you should have router 0, router 1, and router 2. Take a 29, go to switches, take a 2960 switch and put one right in the middle. Okay? Once you've done that, go to PCs, grab 3 genetic PCs, put the first one here, it'll be PC 0, put another one on the top, that will be PC 1, and put another one right here, that will be PC 3, PC 2, I'm sorry. Okay, with connections, grab a crossover cable. Well, actually, straight through cable. And go from fast Ethernet 00 to 01. And then grab another one from 00 to 01, from 00. Fast Ethernet 00 to 01. Is that clear? 03, I'm sorry. Here, will be to 02, this will be to 03 on the switch. Okay, but on the routers, it's 00. Then grab a crossover from the fast Ethernet of 00 of the PC to 01. And another one from fast Ethernet 00 to 01. From the fast Ethernet of the PC to fast Ethernet 01. Once you have this connection, this is our networks. I just made them up. This is one LAN, this is another LAN, and this is another LAN. This is a multicast access OSPF. So this is the area 0, right? And this is the network. So 12.13.14/29, this is going to be .1, 12.13.14.1, 12.13.14.2, 12.13.14.3. /29 means the subnet mask is 255.255.255, 3255.248. Remember that? There, here, and there. Okay, so let's go to PC 0 first and configure it. So let's go to PC 0, and here's the configuration. It's 192.168.10.1, the first address. The subnet mask is /24. There it is, 255.255.255.0. And the default gateway, which is right here, I chose the last IP address, which is 192.168.10.254, right? Let's go to the PC up here, PC 1. And we got what? 172.16.100.129, right? That's the first address. The subnet mask is /25. So there's your /25. It ends with 128. And the default gateway, which is right here, is 172.16.100.254. Okay. Let's go to the other PC. And it's 10.20.30.65, the first address. The subnet mask is /26, so that means it ends with 192. And the default gateway is 126. It ends with 126. Okay, so that's that. Now let's go and configure the routers. I already did that for you, so here's what we're going to do. You type en config t host name R0. It's already been done for you. And don't forget, no IP domain look up, right? Go to interface fast Ethernet 00. Here, in fact, you know what I'm going to do? Once you're right there, don't do anything. Just wait. I'm going to show you. I'm going to do show run. If you type interface fast Ethernet 00, then you type IP add 12, 13, 14, 1, 255, 255, 248, and then type no shot. Okay? You know what? Let me do it for you. So this way you'll see what I'm talking about. Config T. Go to interface fast Ethernet 0/0. And then the IP add is, what is it? 12, 13, 14.1. And it's a /29, which is 255, 255, 255.248. And you just type no shot. Remember, this is fast Ethernet 00. This is the fast Ethernet 01. So let me go to interface fast Ethernet 0/1 and then type IP add 192.168.10.254 with subnet mask of 255, 255, 255.0, and then you type no shot. That's all you have to do. Okay? You go to router 1 and do pretty much the same thing. Enable. I'm going to show you the show run. Do enable config T, host name R1. Just write that down, right? After you do the config T. And then you type no IP domain lookup when you're done with that. Type INT space FA 0/0. And then you type IP add 12, 13, 14.2, subnet mask 255, 255, 255, 248. Hit enter and type no shot. Once you're done with that, then type INT FA 0/1. Then you say IP add 172.16.100 254 space 255.255.255.128. Don't forget the dots here, all right? Don't put spaces. And then hit enter and say no shot. That's it. You should have these active. Green. Let's go to router 2. Okay. Type en config T. Let me go to show run. After you type en and config T, type hostname R2 right here. Enter. After you're done with that, type no IP domain lookup. Enter. And then you type INT FA 0/0 and then IP add 12, 13, 14, 3, 255.255, 255, 248. Okay. And then type no shot. Don't worry about anything else that you see in here. We'll talk about that later on. Go type INT FA 0/1 and give it the IP address. This is a /1 right here. 10.20.30.126. 255, 255, 255, 192, and then type no shot. All right, once you have all of these active, now you are ready to run OSPF. This is the area. So let's start with this router right here. Now to activate OSPF, we're doing version 4. What you do is you say router OSPF 1. That number 1 is called a process ID number. And they don't have to match. It could be any, this is just a process that the router remembers. You can change it to any number you want, but typically we keep it as the same number as everybody else, so it's easier to remember. So that's how you activate OSPF version 4 on the router. Hit enter. Okay, now once you do that, now we need to activate or advertise this network and this network right here. So let's advertise on the one on the fast Ethernet 01. So what I'm going to do is I'm going to say network, and this you type in the network itself 192.168.10.0. Now with OSPF, you have to write something next to it called the wild card. The wild card is considered to be the inverse of the subnet mask address. What's the wild card equal to? Here, I'll show you. I'm going to go down here and I'm going to say wild card. This to calculate the wild card, what you do is you write 4 255s and then you subtract minus, well, I'm going to write the word minus your slash number. What's your slash? It's a slash 24, right? And what's slash 24 equal to? 255.255.255.0. Okay? What's the result? What's 255 minus 255? That's 0. Dot. What's 255 minus 255? That's 0 again. 255 minus 255? That's also 0. What's 255 minus 0? That's 255. So this is your wild card, right? 4 255 minus your slash gives you your wild card. So let's go back and write our wild card. 0.0.0.255. Now also you have to say I am in area 0. You have to write that at the end of the advertisement. You have to write area 0, and it's always area 0. It's never anything else. Okay, now we have to advertise this side, right? Which is network. What network is that? That's network 12, 13, 14, 0. So we will write 12, 13, 14, 0. What's the wild card for slash 29? So let's go back and recalculate that. So the wild card for slash 29 here, 255.255.255.255, right? Let me just move that over. Slash 29 is what? 255.255.255.248, right? And what's the result? 255 minus 255 is 0. Another 0. Another 0. 255 minus 248 is 7, right? So there's my wild card. 0, 0, 0, 0, 7. So I go back, and that will be my wildcard space 0007 area 0. That's it. And then make sure that the fast Ethernet 01 has a passive interface on it, so the updates doesn't go in. So type PAS, hit the tab key, FA0/1. This side right here. No updates going into fast Ethernet 01. Not 00, 01. Enter. You don't have to type no auto summary because the router does that automatically. That's it. Let's go to router 1 and do the same thing. Here, I'll show you. Do config T. Actually, we did it right here. See, I did it already because I was testing it before you guys did it. But type router OSPF1, right? And then you're going to say, here's the network that you're going to advertise. I'm just going to highlight it. Copy. Because it's done already. Why bother doing it? Here's the network. And the network is this, 172.16.100.128, right? So you write that down. And then the wildcard for /25, if you do it the same way we were doing it, it comes out to 0000127, and make sure you write area 0 after that. And then you write this network. Again, inside you want to advertise this network too. Right? So you go in and you say network. It's exactly the same network that we did here. It doesn't change because they're sharing. This is a multi-access area. Multi-access means they are on the same network. And there you go. And then just make sure you write in passive interface on the fast Ethernet 0/1, right? So that the updates doesn't go in there. That's it. Let's go to router 2 and do pretty much the same thing. As you can see, I did that already as well. So do config T, router OSPF1, and let's do this network first. Copy, paste, right? That's the network, and this is the wildcard for the /26. Okay, and here's the other network. You don't have that. You have to type these commands in, okay, and paste it. Don't forget the area 0 at the end. And then make sure you have a PAS tab key, FA 0/1. And that's 0/1 right here. Now, if you go, let's stay on router 3, do Control Z. I'm sorry, router 2. Type show IP route. And there is your OSPF. You should see router 1, router 0, and router 1 network. This is router 1, and this is router 0 networks, right? And they came in from my fast Ethernet 00, right? If you go to router 1, do Control Z and type show IP route. You'll see the same thing, right? To fast Ethernet 00. You see that the administrative distance for OSPF is what? 110. What's the administrative distance for RIP2? 120. Remember that? All right, it says it's 2 hops away. That means you go from here, from the router to get inside. And the bandwidth is 2. That's the cost, which we'll talk about that later on as we move along. Okay, so OSPF version 2 is running. Now, you can go in and say, let's say, who is the designated router? Well, first of all, the priority, here, let's go to router 2 and type show IP interface, show IP OSPF, show IP OSPF interface fast Ethernet 0/0. And you see that it has a priority of 200. I already set the priority of 200 on it. I changed it from 1 to 200. Well, that's a bad example. Don't look at it. Let's look at this one right here. Control Z and type show IP OSPF interface fast Ethernet 0/0. Misspelled OSPF, so let me just fix that. And he is a DR others, so that means he is not the designated router because he has a priority of equal to 1, right? Here's his router ID number, correct? Now for router 3, he is the designated router because he has a higher priority number. I changed it before that. How do you change the priority number? Let me go ahead and make sure that this guy gets the priority number of 300. So how do I change that to make him as the designated router 0? So I go back and I say config T. I go to the interface fast Ethernet 0/0. Remember that from here to change the priority number. Go back up here. You go to the interface and set the priority number, right? So I'm going to the interface and I say IPOSPF priority 300. IPO, what did I miss? IPOSPF priority. IPOSPF, unless it's not doing it right. Oh, it cannot be more than 255. Okay, so let's say 255. Okay. Now I can do Control Z, clear, clear IP, and we want to clear IP OSPF processes so it can take over. Say yes when you hit enter. And now when you're ready, it reloads without loading everything. And now when you type show IP OSPF interface fast Ethernet 0/0. Check it out. Where are we? He is the designated router now because he has a priority of 255, right? This guy, he's going to be the backup. So let me see. Now he has a DR others now. Actually, then he should be the backup designated router. Now, if you wanted to change the interface router ID number, what do you do to change the router ID number? You go in. By the way, the dead time interval, here, let me go to router 1. See the dead time interval, right? The hello interval is 10 seconds, and the dead time interval is 40 seconds, right? So you can go to that interface, config T. It should be, leave them alone. Usually we never bother changing because if you change those, the hello interval and the dead time interval, they're going to be different than the other two. And then what happens, they will not create adjacencies, and therefore you will lose the connection between the other routers. So you go to the interface fast Ethernet 0/0, and then you type IP OSPF. Here are your different choices. You can create an authentication if you want. You can change the cost, the dead time interval, and the hello interval. Just type dead time interval here, dead time interval, and just put in a number, 40, 50, 45, whatever. We're not going to change that. So you can change all the priority number we just did, right? You got to go to the interface to change any of those. Now, if you want to do the router ID number on that, instead of picking the loopback address or the highest active interface, you got to say router OSPF 1, and then you say router dash ID, and then you type in 1.1.1.1, for example, right? And that's your router ID number. But I'm not gonna, it says clear IP OSPF for it to take. This is like reloading if you want it to take effect. All right. So you have to do. That's how you change the router ID number, the OSPF router ID number. All right. Let's continue. We're gonna get to how to configuring IPv6 version is even easier. Let's continue with the slides. All right. So this is how you will configure OSPF for IPv4. Make sure you type in the network. This is called the wildcard. Again, this is /24, right? Don't forget area 0. This is a link, which is 255, 255, 255, 252, right? Because 255 minus 254, 252 is a 3. All right? Don't forget that. Passive interfaces. Make sure you put the passive interfaces on the networks in the LAN, so you don't create a lot of traffic and inefficient use of resources and security. So passive interface, anything into the LAN interfaces, right? We've done that already, right? So we did this already. All right, now how do you configure the metrics, the cost? How do they pick the best route to the destination? And the way it does it is it takes a reference bandwidth, which starts at 100,000, 100 million, divided by the actual interface speed. So if the actual interface speed is, for example, 100,000, 100 million, which is a fast Ethernet, so 100 million divided by 100 million, that's equal to 1. So the cost is equal 1, right? Anything that is higher than like gigabit Ethernet or 10 gigabit Ethernet, which is 100 million divided by 10 billion, is going to be less than 1. So they'll round that up to 1. So anything that is faster than 100 megabits will be considered as 1. You can change the reference bandwidth, by the way, to something much higher so you can actually change these numbers, right? And the way to do that is and by the way, this is how the metric, by saying you can change the actual cost itself. This is the added cost of all the bandwidth to your final destination. That's where you see it. Now, you can do it on the gig auto cost reference of 100, 1000. That's going to be in megabits. Okay. So remember that's expressed in megabits. So 1000 megabits, that's going to be a giga. The 10 gigabit auto cost reference is 10. So you automatically make that as the reference as 10, what is it? 10,000 megabit, which is 10 gigabits as the reference. So you get a 1 after it. Now, the default interface bandwidth on the Cisco routers are always set to a T1 line, which is 1.544 megabits per second. So if you change that interface to something higher, that default will always be the same. So you got to be able to change this bandwidth to something else. And the way you do it is just by typing the command, go to the serial port, type the command bandwidth, and just write in the number. It's automatically known that this number is in thousands. So you just write 64 and it automatically changes to 64 kilobits per second. So if you want to change the bandwidth, and then the cost, of course, will be calculated using this number. Is that clear? So you can actually change the bandwidth on that interface to any number you want, and the cost to calculate, you will use this bandwidth. Remember, it takes the reference bandwidth divided by this number to get the cost. All right. So you can change the costs too without changing the bandwidth. So you can say IP OSPF, the cost is this number, and that's it. You don't even have to worry about what the bandwidth is. I mean, you have that flexibility to do with OSPF if you wanted to do that. To verify that OSPF is running, you can type show IP OSPF neighbors. I mean, we can do that in the topology that we did. Um, You can verify that OSPF protocol is running. Like I said, show IP protocols will display the routing protocols that are running on your router. And in this case, you have running OSPF with process ID number 10. Show IP OSPF alone will give you everything that is and a lot more details, maybe stuff that you probably don't need, like the LSAs and the LSUs and things like that. Show IP OSPF interface briefly display everything that is running on OSPF. Here's the one, process number 10. It gives you all the IP addresses and the subnet mask that it's being neighbors to. Okay, let's take a look at version 3 is pretty much the same thing. There is really no major difference in terms of running OSPF. The similarity is pretty much they're still link state. They're still using the same algorithm. The cost is calculated the same way. Still same areas. You got to start with area 0 as the backbone, and all the other areas connect to it. The hello packets, all the packets that are being exchanged between routers are pretty much the same thing, right? Backup and the designated router and the backup designated router is the same, and the router ID is still a 32-bit number. Okay, it has nothing to do with IPv6, so you can set up a router ID the same way. Now, the differences between version 2 and version 3 is that, of course, in version 3 we're going to use IPv6, the advertisement of the addresses. The source address is going to be IPv6, the destination address. Now, when we send out the updates, we're going to send them on IPv6 addresses, FFO2, colon 5, and FFO2, colon 6. That's for the multicast routers, multicast address. This is for the multicast addresses for all, to send it to everyone else. All right, advertise the network. It's much even easier. We use the network address, remember? Here now we're going to go to the interface and type IPv6 OSPF, the router ID number, and then router area 0. Okay, in fact, we could do that right now. Just make sure that we type IPv6 unicast routing. If you don't type that command, you're not doing the dual stacking, remember? And we're not going to do any authentication. We'll do that later on. Right? So the link book addresses will be advertised as well. And here, let's do that right now. So what we're going to do is we are going to configure IPv6. So what I'm going to do, I'm going to leave that on the side because I want to copy the same thing over the same. Well, we don't have to copy the same addresses. So here's what we're going to do. We're going to go to router 0 and we're going to do config T. And we're going to do IPv6 unicast routing. Now we're doing dual stacking, right? And let's go to interface int FA0/1, which is this interface right here, right? Let's give it IPv6 add 2001. I'll just make up my own 2001 08 dB ACAD :1 1/64, right? And then I'm going to do relay this and change. I'm going to do the link local, do FE80, and then L link local, right? Now, let me go to interface, fast Ethernet 0/0, which is right here. And I'm going to say IPv6 add 2001 08 dB colon ACAD colon. Let's say this is subnet 2 inside This multicast will be subnet. Let's make it subnet 2. No, we'll make this subnet 1, subnet 2, subnet 3. Let's make the multicast subnet 4, right? So this way we don't forget. We'll make it subnet 4. Calling, and it'll be the first one here. He's the first one in subnet 4. /64, right? And we are going to give him a link address to, he'll be the first one, FE80. He's also going to have a link address too. Okay? So he's going to be in subnet 2 with link address 2, right? Yeah, he could have his own subnet. So let's go to this router right here, router 2, and we're going to do en config t. Let's go. The first thing we're going to do IPv6 unicast routing. Then we go to interface fast Ethernet 0/1, which is right here. And we're going to say IPv6 add 2001 08 dB colon ACAD colon. Now we said we're going to want him to be in subnet 2. Let him have his own address, right? One slash no colon 1/64, right? And we get rid of the /64, and he's gonna have an AIP add FE80, and it's gonna be a local link address. Let's go to interface fast Ethernet 0/0, and we're gonna say IPv6 add 2001 colon 08 dB colon ACAD. We said that this is subnet 4, and he's going to be the second address, colon second address, /64, right? And we want him to be the second address for the local link too, right? FE80, that's going to be his local link address, FE00, right? Good. So I think we're doing good so far. Let's go to router 2 and do en config t. Let's do IPv6 unicast routing, right? And let's go to interface fast Ethernet 0/1 and say IPv6 add 2001 08 dB colon ACAD colon. This is going to be subnet 3, and he's going to be the first one in it, /64, right? And in the inside, it's going to be, he's going to be the third. Yeah, oops, no. He's going to have FE also, FE80, and that's going to be his local link, right? Let me go to interface fast Ethernet 0/0, and we're going to say IPv6 add 2001 08 dB 08 dB colon ACAD. This is inside subnet 4, colon, and he is the third guy in there, right? /64. And we'll leave him as the third guy for the local link as well. FE80 as well, right? Now, that's it for configuring the interfaces. Let me go to the PCs, go to the PC and do auto. Make sure you get the IP addresses. Go to this PC, get the auto config, do the slack on all of them. Good. All right, he's in subnet 2. Let me just make sure this guy's in subnet 1. Good. And this one should be in subnet 3, right? Do the slack on this guy, and he's in subnet 3. His default gateway is FE01, right? We're all good. Now, how do you configure OSPF between them? Very easy. Look how easy it is. It says go to the interface and just say, well, actually, it doesn't even tell us right here. I'll show you. After you do that, this is actually showing us what we just did, configuring the IP addresses on the interfaces, right? So once you do that and double check the IP configurations, we did this already, we did that already. I just showed you how to do that. You could do the router ID numbers if you want, changing the auto reference number to a 1000, which is 1000 mega, which is a gigabit if you wanted to do that. All right. Changing the router ID is the same thing. But what we wanted is this. Just go to the interface and say IPv6 OSPF1 area 0. So here's what we're going to do. You just go in to the here and go to interface fast Ethernet 0/1. Oops. INTFA 0/1. And you say IPv6 OSPF, right? Let me see here. OSPF, what is it? 1 we said? Area 0. Then we go to interface fast Ethernet 0/0. And you say IPv6 OSPF, process ID number 1, area 0. Done. See how easy it is? Once you configure the interfaces, you go to the router up here, go to interface fast Ethernet 0/1. You say IPv6 OSPF1 area 0. Then we go to the interface fast Ethernet 0/0. You say IPv6 OSPF1 area 0. You're advertising both. And then you go to the other router, router 2, and you go to interface fast Ethernet 0/1, and you say IPv6 OSPF1 area 0. And you go to interface fast Ethernet 0/0, and you say IPv6 OSPF1 area 0. All right. So if you type do Control Z, pretty much done. Show IPv6 route. And it doesn't show any OSPF unless we do it. Let me see if OSPF. Oh, it's still loading. Still loading. You got to give it a chance to load. If you go to router 0 and you do Control Z and you type show IPv6 route, and you see it right here. There you go. See, it starts showing up on router 0. Let's see if this one is running. Yeah, there you go. They're coming. Just give it a chance because it takes time. Let me see. See, it's loading up. So let me go to router 1. Now I repeat the command. And now I see the 2 O's for router 6, for IPv6. You go to router 2 and you do Control Z and type show IPv6 route. And you should see 2 O's. There you go, 2 O's, right? if you go to router 2 and you type show IPv6 route, and there's your 2 O's. Okay? Make sure you save this and you submit that along with this homework, right? For homework and a couple of questions that I asked. All right, let's continue. We're almost done. So that's how you would configure IPv6 using OSPF. This is OSPF version 3. All right, you could type show IPv6 OSPF neighbor, and it will show you that. It will show you who your neighbors are and their router ID numbers, right? Show IPv6 protocols. It will show you the OSPF with the router ID that it's running, right? Show IPv6 OSPF interface brief. You could try any of these commands. We just did this, right? Show IPv6 route, right? That's pretty much it. So don't forget the packet tracer that we configured, because that will show me that you did version 4 and version 6 configuring OSPF and a multi-access. Don't forget we talked about the designated router and the backup designated router. So I want you to write that information. And the first couple of questions, you can include both on the same sheet. If you wanted to include this, how to calculate the wildcard, because we are going to use that when we get to class and we do the hands-on. So please submit both of those things as homework. All right. So I think this will end this chapter. I know it's a little bit long, but hopefully this was informative. And until we meet again in chapter 9, keep up the reading, by the way. Make sure you read your books and be ready when you come to class to do some hands-on. All right, until then, God bless.